We're going to cover Dalton's Law now. The law is really simple. Total pressure equals all the partial pressures added together. That's it. So, for example, in number 1, we have the air contains oxygen, nitrogen, carbon dioxide, and some other gases. What is the partial pressure of the oxygen? At 101.3 kPa of total pressure if the other ones are as follows. So basically all I have to do is, since the total is going to equal the other ones put together, okay, well then the oxygen one, PO for oxygen, is just going to equal the total subtract the other one. So it'll subtract the CO2, subtract the nitrogen, and the one for the other gases, we can just like OTH for other, and that's it. So our partial pressure of oxygen will be the 101.3 subtract the 79.1 subtract the 0.040 and subtract the 0.94. And so the partial pressure of the oxygen basically is just 21.22 kPa. Pretty straightforward. Okay, number 2, determine the total pressure of gas mixture that contains oxygen, nitrogen, and helium. We're told that the partial pressures, oxygen 0.197 atm, nitrogen 0.461 atm, and the helium 0.264. So again, total pressure just has to be, in this case, the oxygen, the nitrogen, and the heliums combined. So 0.197, 0.461, and the 0.264. And our total pressure in this case is 0.922 atm. The T for total. Number 3, gas mixture containing oxygen, nitrogen, and CO2 has a total pressure of 32.9 kPa. If the oxygen is 0.0652 and the nitrogen is 172.6 millimeters of mercury, what is the CO2? Now, in this case, okay, this only works if everybody's in the same units. So my total pressure is in kPa and the other two are in different things, so I need to make them all be the same. So for instance, we could go to kPa. So for the PO, well, that's going to equal 0.0652 atmospheres times 101.325 kPa over 1 atmosphere. And so 0.0652 times 101.325. This one comes out 6.61 kPa. The nitrogen is 172.6 6 millimeters of mercury. So again, it'd be times the 101.325, but this time over 760 millimeters of mercury. And we get 23.01 kPa. So total pressure, okay, has to equal the PO, the PN, and the PCO2. So our PCO2 is going to be the total, the 32.9, subtract the oxygen, 6.6, and subtract the nitrogen, 23.0. And so the CO2 is 3.3 kPa. Any questions so far? Just had to have the units all in the same. Okay, number 4, gas mixture containing oxygen and nitrogen has a total pressure of 600 millimeters of mercury. If the pressure is 80% nitrogen, what is the partial pressure of the oxygen? Okay, well, you know, we have 80% here. Okay, the way percent works is it's always the part out of the total. So basically, the PN, okay, that's 80%. 80% as a decimal is 0.8 times the total. Okay, that's the way all percentages would work. Okay, it's 80% of the total. Well, in that case then, it's 80% of the 600 millimeters of mercury, which in this case would be 480 millimeters of mercury. Okay, well, we want to know the oxygen, so we could simply, in this case, then just go that the oxygen has to equal the total, subtract the nitrogen, or 600 subtract the 480, which is 120. So the oxygen is 120 millimeters of mercury. Now I might mention you could have also said, well, if I only have the two gases and the nitrogen is 80%, then the oxygen is 20%. Subtract from 100%. And therefore I could have just done 0.2 times the 600 as well and gotten my answer. Okay, partial pressure of water vapor in a greenhouse is 138.6. So that's the pressure of the water vapor, and that's 18% of the total. So again, the partial pressure of is 18% of the total. In this case, the water pressure, that's 138.6 millimeters mercury, equal to 0.18 of the total. So the total would be the 138.6 over the 0.18. Which is 770 millimeters of mercury. Any questions?